Hello, everybody, and welcome to part 2 of our Chapter 3 lecture. In this lecture, we are talking about different types of variables. We've talked about different types of claims, 3 causal claims. We talked about frequency claims, association claims, and causal claims. And then we're going to be talking about validities as well. And I broke this section up because there is a lot of terminology in this chapter. And so I want you to take the time, I'm hoping, to listen to the lecture, read the book a couple of times, because all of these terms can sometimes get confusing, even though what I'm trying to express to you isn't that complicated in most cases of an idea. Because of all the terms, and sometimes they all sound kind of similar, they can get confusing. So take your time with this chapter. All right. We were here on this slide about interrogating causal claims. And if you recall, a causal claim is one that you would be able to make if you do an experiment, meaning you have an independent variable, that's a variable that you manipulate, and you look at the effect on a dependent variable. So one of the keys to an experiment or a causal claim is manipulating one variable and measuring the other. And we talked about the other very important part of being able to have a causal claim is that you have randomly assigned people to groups, that people don't choose the groups they want to be in, you randomly assign them to groups. Now, if you're reading a study about an experiment and you're interrogating, this means you're thinking about the causal claim that the author is making. In your mind, you're saying, can they really make this claim or this argument that they're trying to make? Because in an experiment, they're trying to say, changing something about the independent variable leads to an effect on the dependent variable. In order to be able to say something about causation, we need to be thinking about these 3 criteria. The first is the criteria of covariance. You see that here, covariance. And that's saying that the study's results show that as A changes, B changes. Okay, so as your independent variable changes, the dependent variable changes. They co-vary. They vary together, or they change together. That's the idea of covariance. And it can be that high levels of the independent variable go with high levels of the dependent variable, and low levels of the independent variable go with low levels of the dependent variable. Or it could be the opposite. It could be that high levels of the independent variable go with low levels of the dependent, and that low levels of the independent variable go with high levels of the dependent variable. Doesn't matter, it just means that they vary together. So again, if we were looking at sleep and the effect of sleep on test scores, we would want to see that people who tend to sleep more tend to have higher test scores. People who tend to sleep less the night before a test tend to have lower test scores. Something like that. You want to see a pattern in the results. That's the idea of covariance. Now, that's not all we need. We also need temporal precedence, and temporal meaning time, and that the study's method ensures that the independent variable comes first in time before the dependent variable. Well, that should make sense. If you want to see that changing the independent variable affects the dependent variable, you need to be sure that the study's design changes the independent variable first and then measures the dependent variable. For example, if you want to look at the effect of sleep on test scores, you would want to be sure that, and remember we have 2 groups. We've got that one group that doesn't sleep at all the night before a test, and another group that gets to sleep 8 hours the night before a test, and then they take a test, right? If we want to see temporal precedence, we want to be sure that we manipulate sleep the night before the test, right? Let's say it's Sunday night. Sunday night, one group doesn't get to sleep at all, and Sunday night, the other group sleeps for 8 hours, and Monday morning they take a test, and then we compare which group does better. If we see that the group that sleeps 8 hours does better on the test than the group that sleeps for 0 hours, we can start to conclude that sleeping affects test scores. However, you can see it wouldn't make any sense if everyone took a test Monday morning and then Monday night you had one group sleep for 0 hours and one group sleep for 8 hours, and then look at differences in their test on Monday morning. If there was a difference in their test scores on Monday morning, when what you manipulated happened after that on Monday night, it wouldn't make any sense to say that sleeping somehow affected those test scores. So you would want to be sure that the design was set up so that the manipulation happens before you measure the dependent variable. And then lastly, the idea of internal validity. Internal validity, and we're going to talk about this quite a bit. Internal validity means how certain are you about your conclusion about cause and effect, that there are no other plausible alternative explanations for the change in B, meaning the dependent variable, that the only thing that really makes sense as to why the two groups are different on the dependent variable is the independent variable. So again, going back to our idea of test scores and sleep, if on Sunday night we had college students and one group slept 0 hours and one group slept 8 hours, and then Monday morning we gave everybody a test. Well, if we gave the group that slept 8 hours a very easy test and the group that slept 0 hours a very hard test, and we found that the group that slept 8 hours did better, well, we have a problem with internal validity. Are we sure that it's sleep that impacted test scores, or could it be the type of test we're giving them? Right? That makes sense. What if we had our two groups, and one group slept 8 hours, one group slept 0 hours. We gave them all a test, and we found out that the group that slept 8 hours again did better than the group that slept 0 hours. But we found out that we didn't know how to break up people into groups, so we put all the college seniors in the 8 hours of sleep group and all the college freshmen in the 0 hours of sleep group. So now if they do better, the 8 hours of sleep group does better, are we able to say it was sleep? Well, we have a confound, or again, we have a low internal validity. We have another explanation. It could be that college seniors do better on the test because they've been in college longer. They have more education, and so they did better on the test than college freshmen, because we have that systematic difference between the groups. If we give the tests at different times of day, if we have one group take the test in a room with white walls and one group take the test in a room with blue walls, well, is it sleep, or is it the color of the room or the temperature of the room? The idea here is that we want everything to be the same between the groups except for the level of the independent variable. And again, we'll talk more about this as we talk about experiments, but internal validity is really when you're thinking about the study, when you're reading about someone's research study, is there any other explanation for why you're getting a difference in your results? All right, and so then this sums up the type of claims, and we've talked about this. Frequency claims, you're just looking at one variable, and it's giving you something like 4 in 10 teens admit to texting while driving. We had this discussion before in my previous lecture that admit is a key word there, and how many actually do it. And again, my public safety announcement, please don't text while you drive. 42% of Europeans never exercise. Middle school kids see 2 to 4 alcohol ads in a day. So this is just giving you kind of the frequency of one particular variable. Association claims are based on two variables that are measured. So we're just looking for an association between two measured variables. Single people eat fewer vegetables. So we would ask people, are you single or not? And how many vegetables do you eat a day? And then we're just looking for an association. And you can continue reading these. And then causal claims, remember for a causal claim, we have two variables, but we have an independent variable that we manipulate and a dependent variable that we measure. So you have a manipulated variable and a measured variable. Music lessons enhance IQ, and we saw that again in the part 1 of this video, that if we assign individuals to different types of lessons, randomly assign them to different types of lessons, and then we measure their IQ, we found that the children who took the music lessons ended up with higher IQ scores. Oh, this was just a cute one. You could pause this here. You know me, I've been talking, I do like shopping. Here's a gifting. And you could see if you can figure out if it's a frequency claim, an association claim, or a causal claim. So you might want to take a little bit and just see if you could figure those out on your own. All right. Also, all claims are not based on research. This is a research methods class, and we're focusing on research. But what we read about in the popular press are often not based on research. Some of these claims are based on people's experience, based on their intuition, or based on authority. And we talked about why there are flaws in basing claims on experience, intuition, or authority. For example, a 12-year-old's insights on autism and vaccines goes viral. So this is her own thoughts, or his own thoughts, on autism and vaccines. That's wonderful and important and maybe very interesting, but it's not science. And so as you're reading a headline, as you're reading an article, you want to know, was this an actually empirically based scientific research study, or is this just somebody writing about their thoughts and ideas? This happens all the time on internets, on blogs, and sometimes you don't even know you're reading an opinion blog. They look very official, but they are not. And so you really want to be careful about what you're reading and where that information is coming from, because as we said, research or claims based on experience, intuition, or authority can be wrong. Last part of this chapter, and again, we're going to introduce these topics now, and we will continue to talk about them throughout the semester, are the 4 big validities. The idea of construct validity, external validity, statistical validity, and internal validity. And again, as you're reading a research paper, you're going to be thinking about these validities. Does this paper kind of meet all 4 of these criteria? And if not, why? What are you thinking about? So let's talk about construct validity. Construct validity is how well the variables in a study are measured or manipulated. So the constructs are what you're trying to study. The construct of, again, let's go back to our our experiment about sleeping and test scores. So my variables are how much somebody sleeps. That's one construct I'm trying to manipulate. And then test scores, right? I'm interested in test scores, and that's what I'm trying to measure. So you would want to look at, in the research paper, how did I manipulate sleep? Did I just tell people, hey, you shouldn't sleep at all at night, and send them all home for my no sleep group, and the other group say, hey, you should sleep for 8 hours? Well, how would you feel about that? And then come to the research lab in the morning? Is that a very good manipulation? I don't know, because if I told you not to sleep at all, would you be sure you didn't sleep at all? How do we trust that? How do we know that? If we told someone to sleep 8 hours, would we be sure they slept 8 hours? Versus maybe I bring them into a sleep laboratory and I am sure that my research assistants are keeping awake the participants in the no sleep group, and I am monitoring the sleeping group and assuring that they're asleep for 8 hours, and once 8 hours hits, I wake them up. That would be a better manipulation. And so how am I manipulating that construct? Now, in the same experiment, I'm also measuring test scores. And so I guess my question would be, what kind of test is it, right? Did I give everybody, maybe these are college students, and did I give everybody a fourth grade math test? I don't know. Would sleep really affect a college student's ability to do fourth grade math? Probably not. Did I give everybody a calculus test, right? That might be too hard of a test. And so sleep, and maybe everybody is going to do poorly, and we end up finding that there's no effect of sleep on test scores because both groups did really poorly. Well, maybe it's because the test was too hard. So as I'm thinking about construct validity, I'm thinking about the variables that we're trying to measure and how well they were measured in the research study. External validity, this is the extent to which results of a study generalize to a larger population, as well as to other situations. All right, so external meaning outside of the research study. When we do a research study, very typically we do it in a research laboratory, right? Imagining again, sleep and test scores. And so I have participants, college students who come into my sleep laboratory, and I keep them up all night, or if they're in the no sleep group, or I monitor their brain waves and I'm sure they're sleeping for 8 hours, and then they all wake up and I give them a test. Well, that's a very, I don't know, unnatural situation, and it's only on a particular group of people. It's maybe 50 people, 25 in one group and 25 in the other group. And so my question for external validity is, can I apply this research to other people outside of those 50 people? Because I truly want to do a study to say something about more generally the whole population, all of society. Can I say that sleeping is really important if you want to do well on tests? Not just for those 25 people in each group, but for everybody. And so that's when you look at the population, you look at the group of people that you studied or your sample, and you start to say, well, they were all college students. So if I find that sleep does affect test scores, could I say that affects or that would hold true also for second graders? Could I say that what I found also holds true for 70-year-olds? Well, if I only studied college students, then probably I could only expand my results to other college students. And what if I did my study only on psychology majors, right? That happens a lot. Psychology researchers, who do we study? We study a lot of psychology students. So could I say that this would also hold true for physics majors or chemistry majors? That's the idea of external validity. Or graduate students. How far out can your results be generalized? And again, to other situations. Would it just hold true in the laboratory, or would you think that your results would make sense in the real world when people are really sleeping in their homes? Or was there something very specific about the lab setting that makes you feel like these results might not translate into the real world? And so that's the idea of external validity. How far beyond your specific, the people in your study and the exact kind of laboratory situation that you created, how far can you extend those results? Statistical validity is the extent to which the data support the conclusions. We're looking at did we use the right statistical test? Could the results be obtained by chance? So this is really checking out the statistics that the person has done. We're going to learn a little about statistics in here. And this would really, you would be able to check on statistical validity as you learn more and more about statistics as you move on in classes. But that's the key, is you're just checking to see, you know, do you think they did the right statistics? It's a little beyond our level here, but nonetheless, we'll learn little bits that you're going to be looking for in those sections. And then, as we said, internal validity, this is the idea that there's no confounds, that you really feel confident in the cause and effect relationship, or do you see a flaw in their study design, in their experimental design, that could make you unsure that the independent variable is causing a change in the dependent variable? There could be an alternative explanation. And this is really based on poor study design. And so again, as you're designing your studies, you want to think about this, but as you're reading other people's studies, you want to think about this as well. And then this is just, you can do these kinds of interrogating validity no matter what kind of claim somebody is using. So for a frequency claim, again, for construct validity, how well is that variable operationalized? That's the idea of operational definitions. How are they measuring or manipulating, in this case measuring, the variable that they're studying? External validity, a synonym for external validity is generalizability. So it kind of means the same thing. How well do the results of the study represent the people or the context besides those in the study themselves, right? For example, I'm just going back here for a second in this 4 in 10 teens admit to texting while driving. Well, they got this information from a sample. Maybe they asked 100 teens or 200 teens. Did they ask you? They surely didn't ask anyone in my family, right? So then the question is, who were these teens that are in the sample? You want to be sure that they represent, they're a good representative sample of teens. Statistical validity, again, not as important now for us. So 80% of college students have been depressed during the last year as an example. For construct validity, they're measuring college students, so how do we know what kind of college students? Are they at universities, community colleges, online colleges, private, public? I mean, you'd want to know that. And been depressed. How are they measuring depression? Are they asking you just to say, are you depressed or not? Are they doing an actual diagnosis by a psychologist or a psychiatrist? Those are the questions you want to ask when you're talking about construct validity. And external validity, how far can you apply these results? Well, kind of wondering about who are these college students. If they're only a small sample of community college students from the Midwest, well, how far can you generalize those results? Can you generalize those results to students at San Diego State, right? Going to school at a large 4-year university in a big city. So you need to think about those ideas as you're thinking about how valid, how far you can take the results of that study. Association claims, again, how well are the variables operationalized? That's construct validity. And external validity, same thing. Statistical, as we said, not as important now. People who multitask are the worst at it. For construct validity, we'd want to know, how are they measuring multitask? How are they measuring better or worse? That would be questions you would want to look at in the research paper. And external validity, who did they do this study on? Was it college students? Was it third graders? Was it working adults? Because that limits how generalizable Maybe they did the study only in females. Maybe they did the study only in males. Again, you want to know who the group was before you can say, this applies to everyone. Probably has to be a little bit smaller. Oh, this only applies to the people who are similar to those in their research study. And again, in causal claims, same things. We have that construct, external, statistical, validity. People who exercise are happier. So construct validity, how are they measuring exercise, right? Is it 10 jumping jacks? Is it running a mile a day? Is it weightlifting? What is the exercise? And how are they measuring happiness? External validity, who was in the study? How long did they do the study? Did they have to exercise for 1 day and they were happier, or 7 months and they were happier? We'd want to know all of that information. And of course, in all of these, we'd also be looking for internal validity. Are there any other alternative explanations? And you could work through this here. Does hearing about scientists' struggles inspire young students? So educational psychologists conducted a study in which children were told different stories about scientists and researchers and tracked the children's interest in being scientists themselves. Pretty interesting study. And this is an example from basically putting into practice all of the ideas that we just used. So, stories told of brilliant scientists affects kids' interest in the field. There's a claim. What kind of claim is this? What are the variables? What validities should we be interested in looking at? Right, this is a causal claim because they use the word affect. Stories affect kids' interest, so they're talking about cause and effect. One variable here seems to be the type of story told, and the other is the kid's level of interest in the field, and so we're interrogating this causal claim. Construct validity, how well did the researchers manipulate stories of brilliant scientists, right? That's one of the variables, is the stories that they told. And so the journalist reports that some kids were told very conventional genius stories, such as Albert Einstein, brilliant physicist, won the Nobel Prize, he's such a genius. Others was told how hard Einstein had to struggle. At one point, apparently Einstein was having such trouble working out the math in his theories that he turned to his friend Max Planck and said, "This is driving me crazy. Can you please help me with the math?" So as we're looking at this, does that seem to be a good way to manipulate the type of story, right? These two stories do seem to differ in the way the researchers are focused on. One emphasized being a genius, and the other emphasized Einstein's troubles. So we could say this manipulation seems well done. Of course, you could think about it yourself and say, do you think it seems well done? Seems pretty good to me, but you can think about it as well. Construct validity continued. How well did they measure the kids' interest in the field? That's the other variable. So the journalist lists several ways interest in the field was operationalized, reporting the author and her colleagues then measured how well students who read the struggle stories did in science tests. So science tests, how well someone does on a science test. She also measured how engaged the students felt about science and how much persistence they demonstrated when they faced obstacles. And so this is, again, the textbook kind of interpretation. Classroom science tests seems a clear way to operationalize performance. We might want to find out more about how engagement and persistence were measured, such as the kinds of items used. Note that science performance and motivation may not be the same. Now, this is where there's a lot of not as much 100% we all have to agree. For me, I don't know. If someone's interested in science, I don't know that their score on a science test would really represent that very well. Because you might be very interested in science and still be struggling on the science tests. So I'm not sure that I like that as a measure of interest in science. But again, this is all, a lot of research methods is thinking, being a critical thinker, and we don't all have to agree. You would just have to support your opinion on this idea. Statistical validity. So again, we're going to skip much of this because again, this is a little more than what you need for this at this point in our class. Internal validity. Was this an experiment? Are there alternative explanations? So this is the fact that students heard one of two stories suggests the study is probably an experiment, in which some students heard about the struggles and others heard about the genius. The journalists report both stories were about the same scientist, but they differed in focus. The journalists didn't indicate if students were randomly assigned to the different stories. Well, that would be key. And this is coming from a journalist description of a research paper. So if you were really interested, you would want to go find that research paper yourself. If researchers randomly assign students to stories, we assume that those who heard struggle stories and those who heard achievement stories were equally equivalent in background. That's what random assignment should do. And if the stories were the same length, reading level, tone, we can assume that it was the struggle aspect of the story rather than anything else that caused grades to improve. External validity. Can we generalize from the 9th and 10th graders in this sample to other students? Would students also benefit from hearing about the struggles of people in other fields, such as art or law? So this is, can these results be applied to other people or other situations? So the journalist doesn't indicate whether the people were a representative sample, where were the students from, etc. And the such subjects in the study only heard stories about scientists and not other fields. So our ability to generalize to students in other cities or other grades is really unknown. When researchers conduct experiments to support causal claims, their priority is usually internal validity and not external validity. We'll talk about that in this class. So probably just to other 9th and 10th graders is all we could apply to. And we don't know if the pattern generalizes to other disciplines. A future study could test this idea. This is how we do research. We very often say, this was really interesting. And listening to 2 different stories about scientists, and that really helped students get more engaged interested in science. And so why don't we now do another study where we talk about artists? And we give them 2 different stories about artists, one about the genius artist and one about the struggle that artist had, and see if that changes interest in art or music or language, right? And by doing these different studies, we learn more. We build up this external validity. And same with people, right? Well, this worked in 9th and 10th graders. I wonder if we do the same study in 3rd graders. Would we see the same results? So let's do the same study in 3rd graders. Let's do the same study in freshmen going into college, right? And the more you do these studies on different groups of people, the more external validity you have. Prioritizing the 4 validities, which is most important? Well, it really depends on what kind of claim the researcher is making and their priorities. It's hard to prioritize everything, and so very often you have to just prioritize certain things in one particular study, like internal validity, and then in another study you might have a higher priority on external validity. Again, we'll talk about this, but basically they're all important, and the researcher has to decide which are the most important priorities for that particular study. All right, thank you very much.